and welcome back. So in this video, we're going to talk about how to convert polar coordinates to rectangular or Cartesian coordinates. So this would be if I gave you a polar coordinate and you really wanted to know what the x and y were instead of looking at the r and the theta. So in order to do this, we're going to need some definitions, and so I'm going to draw a little picture and talk about how we go between the Cartesian or rectangular and the polar coordinates. So if you imagine that we have an xy set of axes and we have some point xy. This would be a rectangular point xy, but it also has a form that is r theta, that's in polar. So we can take this one point and rewrite it in terms of rectangular or polar depending on what we're looking for. And the polar coordinate has a radius r and an angle theta. So what we can do is think of this as a triangle. So instead of labeling the points on the axes as x and y, we can label the sides of the triangle as x and y. Now we have a triangle and we have trigonometric functions that we can use to give us more information. So from this triangle, we know that cosine of theta is the adjacent over hypotenuse, or x over r, and sine of theta is opposite over hypotenuse, y over r. This is actually how we define sine and cosine. We define them in terms of these ratios of side lengths. So the reason I'm bringing this up now is because this gives us a relationship between the r and the theta and the x and the y. So if we just rearrange things a little bit by multiplying the r over to the other side on each of these equations, we get that x is equal to r times cosine of theta, and y is equal to r times sine of theta. So if we knew theta and we knew r, we could just plug them into these equations and find x and y. I just want to mention one more formula because it's going to be important in the other way of converting. So we really only need these two for doing polar to rectangular, but when we switch the direction, we're also going to need to have that x squared plus y squared equals r squared. And this is just the Pythagorean theorem with the triangle. So a squared plus b squared equals c squared, but just with our side lengths. This is also sometimes handy if you just want to check your work and make sure it looks good. You can find your x and your y and plug them in and make sure you're getting the radius squared. But these first two equations are going to be most important for us in this video because we're converting from polar to rectangular. Okay, let's try this out on an example. Let's convert the point 8, 7 pi over 4 to rectangular coordinates. Looking at my point, this is in polar. So this tells me that r, my radius, is 8, and theta, my angle, is 7 pi over 4. So my goal here is to find x and y for my rectangular or Cartesian coordinates. And I'm going to use the formulas that x is equal to r times cosine of theta, and y is equal to r times sine of theta. And I'm just going to replace r and theta with their corresponding values. So I have that x is equal to 8 times cosine of 7 pi over 4, and y is equal to 8 times sine of 7 pi over 4. Now I go to my unit circle, or at least that's how I'm going to do this, to find the cosine and sine values at this angle. So 7 pi over 4 is in quadrant 4, the cosine value is positive square root of 2 over 2, and the sine value is negative square root of 2 over 2. At this point, I'm trusting that you can find a unit circle and do this yourself, or maybe you have these memorized, maybe you're using a calculator, maybe you're using reference triangles, whichever method you prefer. Then I just want to simplify. So I can do 8 times square root of 2 over 2. I'm going to do 8 divided by 2, which is 4, so I'm getting 4 square root of 2. Then for y, I'm doing the same thing, and I'm getting negative 4 square root of 2. And there we go. My rectangular point is 4 square root of 2, comma, negative 4 square root of 2, which is really like 4 times square root of 2, if you need to just think of it a different way. So I just want to take a second and look at this on the graph. So I graphed using Desmos the point 4 square root of 2, negative 4 square root of 2, and I computed what that value is as a decimal. So 4 times the square root of 2 is about 5.65685, etc. So if I look here at the polar graph, we can see that the angle is 7 pi over 4. That's in quadrant 4. And then if we count out on our circles, we're at a radius of 8. So our point here is at a radius of 8, and we're 7 pi over 4. That's the polar coordinates. Then we should be able to see that this matches our rectangular solution. So if we're over on the x by about 5.66, or that's our 4 times square root of 2, we're here, and then we're down on the y, we have a negative 4 times the square root of 2, and we see that this matches, at least from what I can tell, the point that we graphed. So this is just a little confirmation to make sure that we did it right. We did convert it in a way that makes sense. So I want to do one more example just to show you how this works when we use a unit circle value. It's not really as interesting, but I just want to make sure you see the connection between polar and our unit circle. So let's say I want to convert the polar point 1, 2 pi over 3 to rectangular coordinates. So this is a circle with radius 1, meaning we're on our unit circle, and we're looking at the angle 2 pi over 3. So if we were doing our conversion, we would have that r equals 1 and theta equals 2 pi over 3, and we're trying to find x and y. So I would know that x equals r times cosine of theta, and y equals r times sine of theta. Then I substitute in 1 for r, and my 2 pi over 3 for theta. Now I have to go to the unit circle to find these values. So cosine of 2 pi over 3 is negative 1/2, and sine of 2 pi over 3 is square root of 3 over 2. And so these are my x, y values, negative 1/2 and square root of 3 over 2. So because the radius was 1, we didn't really see it show up because we're just doing 1 times these values. And so the solution we get is just the unit circle points, the x and y points. So if you're at a radius of 1, you can just look at the unit circle and those are your points. So there you go. This is why we tend to do examples with different radii, because the ones where the radius is 1 just isn't that interesting since we already have the unit circle and it's easy for us to convert those points. Alright, that's it for this one. I also have a video where we go the other direction. We'll start with rectangular coordinates and go to polar coordinates. Thanks so much for watching, and I will talk to you in the next one.